As another example on processing two-dimensional arrays, this time we want to show you how to process portion of the two-dimensional array, not complete elements of the array. When you read a problem about two-dimensional arrays, while reading the text of the problem, try to look at the example given in the problem itself. This will help you a lot to understand what is required from the program. So by looking at this example, as you see that the rows represents years and the column represents months. Now all what we need to know, what are the numbers inside this matrix represent. Let us read the problem and see what these numbers inside the array represents. It says that employment data is available for each month of the past 10 years. So this line will help you to understand a lot about the two-dimensional array. It says employment data is available for each month. So where is the month? The months are represented by columns in this two-dimensional array. Of the past 10 years, and the rows represents years, and as you see that they are 10. And for the months we have 12. So we have 10 rows and we have 12 columns. So what are these numbers inside the array? We call them entries. They are employment data. Let us see what is required from the problem. It says write a method. So a method is needed to be written named find total employments. So we need to find total, which is sum. This method takes as parameter a two-dimensional array named employment. This is the name of the array of size 10 by 12 that contains monthly employment statistics. So that means here we have inside number of employments, which is called employment data. So inside the array, we have statistics about employment for certain years and certain months. It says each row represents a year and each column represents a month. So now we know what this two-dimensional array represents. It represents employment data, employment statistics for the last 10 years for 12 months. The method should display the total number of employment for the last m months of the last y years, where m and y are input parameters to the method. In addition to the two-dimensional array, employment as input parameter, there are two other parameters that we should supply to the method. Both of them are integers. The first one represents the month and the second represents the year. So the month, it means the column, and the year, it means the row. And what is it required? In fact, it is required to find the total employment for the last. So that means you have to go over the array from last rows and from last columns. So you are going to process only portion of the array. As an example, if m month 3 and y year 5. So we need to find the total of employments for the last 3 months and for the last 5 years. Where are the last 5 years? As you know that rows are the years. So here are the last 5 years. And if we talk about last 3 months and we go for column, and these are the last 3 months. So we need to process only portion of the array, only this part. So we need to do a calculation to tell us where is the row number and where is the column number if we want to refer to the last m months and the last y years. And for the output, the method will display the number of employments in the last 3 months, and 3 is the value of m of the last 5 years, and 5 is equal to y. Now the next question is how to process only this portion of the two-dimensional array. Notice that we are not going to process the entire array. And if we want to find the total, as you recall, we don't need to process the array in a certain way, row by row or column by column. Only what we need to know from where to start, in which row, and in which column. Now, if m is equal to 3, then we are talking about the columns, the month. And for this example, as you know that all indices in arrays, they start from 0. For the months, we have 12 months. The first month is at index 0, and the last one is at index 11. For this data, if m is equal to 3, see that we are at column 9. So this is column 9. So how did we get 9? In fact, 9 is equal to 12 minus 3. And this is how to find the starting column. Now for the rows, you know that we have 10 years. So the first index of the row is 0, and the last one is 9. And from this data, notice that this is row 5. So how did we get row 5? It is in fact 10 minus 5, which is the number of rows, minus the value of y, and it will give you the beginning of the row. So this is what the method is supposed to do. It will start the processing from column 9, row 5, or from row 5, column 9. So it depends how you want to process the array or this portion of the array, row by row or column by column, and it doesn't matter, as we said, that to find the total, you can visit the elements row by row or column by column. So let us go to JGrasp and see how we can implement this method. Here we are in JGrasp. We have prepared a class that we're going to use it as a demo class for the method find total employments. So here we are going to define our method. So it will be public static, and it is a static because we are going to call it within main method, and void because it's not going to return any value. Simply it will find the total and print the total. And the name of the method find total employments. And as we discussed, it needs 3 input parameters. The first parameter is the 2-dimensional array for the employment data, and it's going to be called employment. And the other 2 parameters will be, the first one is the last m months and the last y years. So we are going to process the array, but not all array. It depends on the value of m and y. So first we need to know what is the first row and what is the first column of the portion of the array that we want to process. The first row is computed by subtracting the number of years from the number of rows. So we will define a new variable. We are going to call it first row, and this is equal to employment dot length, which will give us the number of rows minus y, and y represents the number of years. Similarly, for first column, we are going to define a variable called first column, and COL stands for column, which is equal to the number of columns minus m, which is the number of months. And how to find the number of columns? This is not ragged array, so you can pick any row. For example, let's pick row 0 and find its length. Now this will give us the number of columns minus m, and this will give us the first column in that portion of the 2-dimensional array. Now to process that portion and find the total, you have 2 choices, either row by row or column by column. So it doesn't matter if you want to find the total, we will process that portion row by row. So we will write for integer row, and it will start from first row, and row will be less than employment dot length, which is the last row in that portion, and we are going to have row plus or plus. And now for the column, we will say for integer COL equal to first column, and column is less than employment of row dot length column plus or plus. And inside the inner loop, we will find the total by saying total equal total plus employment row and column. And of course, we have to define this variable total and initialize it to 0. So we are going to define it here. Integer total is equal to 0. After finding the total, the method should display a message, system.out.println, and the message is there are, and in here we print the total, followed by a message employment. So there are total employments in the last, and here we need to print the month, which is M, by saying months, and the last, and here we print the year, and we say years. So let us check the message that we don't have any problems. Here we have a problem, so here we need to link it by adding a plus. So the message is there are, and the total will be printed, followed by the message employments in the last M months and the last Y years. Also, we want to modify the output message, and instead of saying and, here we're going to say off, and the message will be employments in the last M months of the last Y years. Now the method is complete. Let us compile it and see if it has any errors. Compile. In fact, there are errors. It says here int, so we have to write int, and also we have misspelling of total. Let us compile again. We have also another error. It says here, yes, we are missing L and it should be employment. Let us compile it again. So now it is free of errors. So now is the time to test this method by writing a small program by generating an array and supply this array to this method. What we want, in fact, is to generate a two-dimensional array with random integers, print this array, and then call the method findTotalEmployments. Notice that printing is one of the common processing tasks for two-dimensional arrays and have been used quite often in our programs, in addition of finding the total, finding the average, finding maximum, minimum, and so on. Therefore, to facilitate the use of these common processing tasks for two-dimensional arrays, we have defined a facility class that includes all of these processing tasks, and from there we can use them to help us in our program generating two-dimensional arrays with random integers, printing, finding the average, and so on. So let us have a look into this class, and then we will come back to show you how to use it in our program. For the facility class, we have created a class called toDimension, and we have included inside it public static methods for these processing tasks. The first one is for finding total for both integer and double as overloaded methods. See, the first one, the input parameter is a two-dimensional array of integers, and the second one is a two-dimensional array of double. The other two are for printing for both double and integer, and the other ones for finding the average, next one for finding the maximum and also finding the minimum, and last for generating two-dimensional array with random integers. The name of the method is called random2dList, and it returns a two-dimensional array. Its input parameters is the number of rows and number of columns, as well as the range of the generated number. For the range, the method generates random numbers from 0 to range. So for example, if range is equal to 10, then the method will generate random numbers from 0 to 10. And also we have included a Boolean variable called include negatives, so that if we want the method to generate negative numbers, we just set this variable, the input parameter, to true. Let us show you how to use this class for our problem finding the total employments. Let us go back to findTotalEmployments demo program and test the method findTotalEmployments. First, we need to generate a two-dimensional array with random statistical employments using the method random2dList that is defined in two-dimensional class. So how to call this method? First, we write the name of the class, toDimension, dot the name of the method, random2dList, and we want this method to generate two-dimensional array of 10 rows for 10 years, 12 columns for 12 months, and the generated numbers in the range 0 to 20. And we don't want negative numbers, we want only positive numbers, so the last parameter will be set to false. This method will generate a two-dimensional array. Its reference will be saved into an array. We will call it employment. We will print this two-dimensional array using the print method that is available in two-dimensional class, .print, and we will supply employment as input parameter. We want to call the method findTotalEmployments, so we will say findTotalEmployments, and we will give the name of the two-dimensional array for the employment statistics, so it's called employment, and we want to see the number of employments for the last 2 months for the last 2 years. So we want a small grid of size 2 by 2 to make sure that the method is computing the total correctly. Now we are ready to test the method. We will first test for errors, and it does not have any errors. Now we run the program. So the program is run. If we look at the last 2 rows and 2 columns, 14 plus 6 is 20, and plus 20, so it is 40. So the method is computing the total employments correctly. So the message says there are 40 employments in the last 2 months of the last 2 years. Let us run it, let's say for another number. Let's say only one for the last year and for the last month. And we run it. And again, it is given the last number, which is 13. So the method is computing the total correctly.